All right, you guys, this is page 3. It wasn't numbered, so I numbered it at the bottom. And there is a lot going on in this graph, and in this page right here. So we're going to start talking about behaviors of a graph of a polynomial. And specifically, we're going to talk about maximum and minimum values. So I'm just going to highlight everything. Global or absolute, we're going to end up using the term global, means that you've got a point that is higher than the rest of the entire graph. And I'm going to go ahead and I'm going to draw what a global would look like, at least a global maximum, but you also have global minimums. So a global max, which I'll label as GM, might look like this. If you had a graph that looked like this right here, that would be a global maximum. It means no point on the entire graph, all right, is higher than it. There is no global minimum on this graph because it goes down forever. I'm going to go the opposite direction. All right, I'm going to show you a global, and since they both start with M, let's call that a global max. And now we'll do a global minimum. Let's say I have a global minimum that maybe it looks like that. That right there would be a global min. So it's a point where no other point is ever lower. And since this graph goes up forever, this graph right here wouldn't have a global max. All right. Now, I should have drawn that down there. Notice I should move them down here. I drew them in the wrong spot, but you can erase or take your notes as needed. There are also local minimums and local max. Well, I want to point out something. A global maximum and a global minimum is a local maximum and a local minimum. They are the same thing. All right. So although this is a global max, it's also a local max, and you have to be really careful on the how they word things. So on this graph, there's one local max. I'm going to circle it right there, and there's one local min. Neither one of them are global because although that's a local min, there are lower points, and although this is a local max, there are higher points. All right. Now, I'm going to go to a next one. We're no longer talking about max and minimums. We're talking about multiplicity, and that's the number of times a root occurs. So if I had something that said x to the first power, that would be a multiplicity of 1. Multiplicity of 1. If I had something that said x squared, that would be a multiplicity of 2. I'm going to write that. Multiplicity of 2. And why this is so important is because a graph behaves a certain way at that root depending on its multiplicity. It's either going to go through, bounce off, or kind of squiggle through. We'll call it a squiggle. And in order to do that, we're going to analyze, in order to see that, we're going to analyze 3 graphs here. All right. And I'm going to show you a quick way to put that on a calculator. So if you have a calculator, this is a TI-82. It's kind of an older calculator, but I didn't have anything with me. I plugged all mine in. So that's every graph that's on here. So if you'll notice, I'll just show you. I put all those in here at once. All right. And in order to do that, now if I want to see one, so if I want to see this first one, and feel free to pause anytime, I'm just going to come here and I'm going to highlight that. So I graphed that out for you. All right, I hit graph, and I have drawn that graph. And you can go ahead and draw that graph. It doesn't have to be perfect. I mean, you're going to show a local max. That's a local max and a local min, right? So it does ask for local max and local min values here. All right, it asks us to identify a global. So these guys would be locals. So I'm going to go ahead and write local. I'm going to write local here, right, because there are lower and higher points. It wants us to pay specific attention to the X intercepts. So I'm going to show you something. My X intercepts come when all these factors equal 0. So if I set x equal to 0, I'm going to have an intercept at 0. If I say x plus 3 equals 0, and let's go ahead and do that. What if I say x plus 3 equals 0? Well, that solves to x equals negative 3. I'm going to have an intercept at negative 3. Obviously, if I solve this, x minus 1 equals 0, the x value would be positive 1, so I'm going to have an intercept at 1. Those would be the solutions when we're solving using what's called a zero product property, which I'm not going to expand on right now, but we've talked about it in class. All right. So I can see this one gives me a root here. right? This one gives me a root here at +1, and this one gives me a root at -3. Now, I've written down some steps on how to use your calculator to find maxes, and I'm going to follow this. So to find my max, let's see if I can have it focus on two things. So I'm going to go find a max. I go second calc, which is right here, and then I go down to my max value. So I come down here to max, and then it's going to give me a cursor. Well, this one says lower bound and upper bound. I think your calculator will probably say left bound, right bound. It could say lower bound and upper bound. I can't analyze the calculator because I only have a TI-82. But you're going to hit enter 3 times. So I'm going to go just left, lower bound of that maximum, and I'm going to say enter. Then it's going to say upper bound. I'm going to go just right of that maximum and say enter. Ooh, I messed up. I'm going to go back to it. So let's hit the graph and second calculate minimum. And maybe I should look at my keys that I hit now. So let's try just left. My first one's just left, enter. My second one is just right, and enter. And then if I hit enter right where I'm guessing it is, it'll give me a value here for my, wow, that said minimum. Maybe I chose the wrong one. So, and I did. So I'm going to go back one more time and say second calc, and instead of min, I'm going to do max. Well, hey. So I'm going to go just left, enter, just right, enter, right at the top, enter, and there it comes. That's my maximum. The word tells me I chose the right one, so maximum. So that's a local max there, and I'm going to show you the values on here really soon, but they're down there. And I'm going to do the same thing with minimum. So for minimum, I go second calc. This time I'll choose an actual minimum. I'm going to go minimum. And it's going to go left to the minimum. So I'm going to come down here, just left of my minimum, say enter. Just right of my minimum and say enter. And then right where the minimum is and say enter one more time. And it's going to give me the minimum values down here. I have written those on there. Right? Here's the steps to finding them on a calculator. Minimum's the same thing, except instead of max, you choose min. And instead of guessing on the max, you guess on the min. And I've put them here, so you can see negative 1.86 and 6.06. And you can see 0.54 and negative 0.88. If you know how to do this, I'd recommend running it through one more time. And we're going to point out that all of these are first power, so that's x to the first, x plus 3 to the first, x minus 1 to the fourth. And at your intercepts, the graph kind of goes straight through. All right, so we've talked about minimums and the behavior at the x-intercepts or the solutions of your graph. All right, I'm going to give you the maxes and mins here. We're going to point out that this one is definitely a global min. It's also a local min, but it's a global min, because this is the lowest point of the whole graph. This one up here would just be a local max. All right, and you can run that through your calculator. You may want to add, these are really high, so I had to change my window to reach these guys. I'm going to show you that I actually adjusted my window, so my y values went lower than, well, I had to go down to 20 to get that negative 16.9. And I had to go up to 15 for my y value to get that 12.4. So what I really want to focus on now is what happens at these roots. So I have a -1 root, so my root is at -1. It kind of shot through that. I have a +1 root. Remember, I'd go, and I'll show you again, x minus 1 equals 0. This would give me x equals 1. My positive root, but look what happened here. This double root, all right, it has a multiplicity, if I'm to use this term up here, a multiplicity of 2. When it hit 4, it bounced off. So this double root bounced off here. It didn't go through at all. All right. Likewise, and I'll show you down here, this double root here at 2 bounced off. It bounced. And I will show you the minimum. That is a local min right there. And at 6, it went through. So take some time and just kind of look at those, right? The double roots here. They had a specific behavior on the graph. That's going to allow us just to kind of look at these graphs, look at these equations and graph them pretty quickly. All right. And if you graph this, and I'm going to show you the graph of this right here. And we're going to try to, I'm going to come down and hopefully I'll show you the squiggle that occurs. So I'm going to highlight this guy. and I'm going to unhighlight this guy. And it actually looks like I did this incorrectly. So I'm going to come over here down to this guy, and I've put that in wrong. I kind of graphed it, but this should be to the power of 3. And let's go ahead and look at that graph, which means my root is going to be wrong. So I'm going to erase this root on here, and we're going to analyze this. But I'd like you to see there is a squiggle here. So whenever you have a multiplicity of 3 at a root, you're going to get something that kind of has that behavior. It squiggles through there. All right, so any odd power other than 1 is going to have that specific behavior. So if you see something that looks like that, you know it's got a power of at least 3, and it's just got this kind of shape. I'll draw it again. It kind of occurs, it balances out, and it's got that point of inflection right there at the root. Obviously, this went a lot deeper here. I'm not going to change my graph over here, but it did go really deep. But I do have to find my global min again. So in order to do that, and here it is, together is kind of a mistake that we'll fix together. I'm going to hit my window, and I'm going to have to go a lot deeper. And I'm not sure how deep, but I'm going to guess really deep. So that negative 20, let's go ahead and make that negative 20 a negative, I don't know, let's see if 50 gets me to the bottom of that graph. And maybe it will. No, 50 is not deep enough either. We can see it's still going down. So let's try, and it looks like we're getting close, but I'm going to go 20 more, and we'll go negative 70. See if that gets to the bottom of the graph. And it sure does. So here we go. We're going to find our min right there. I'm going to hit this button. I'm going to say second, calculate. Minimum is right there, so I'm going to go to minimum. All right. And then here I am. Ooh, you know what? I'm going to do one more thing. It's really hard to see because it's in there. So I'm actually going to make that window even go deeper. Let's go down to 100, and maybe that min will be below. So I'm going to go negative 100, and we're going to look at that graph again. And hopefully this can get it. So we'll go second, calculate minimum, and hopefully it's to where I can see it a little better. Yeah, my words are below the graph. So let's see if we can do this. I can see my cursor is just left. I'm going to hit enter. It says upper bound or right bound, depending on what calculator says. Just right. I'm going to hit enter. I messed up. Go back. Second min. I'm going to use both hands here. Just left, enter. Just right, enter. And then at the bottom, I'm going to hit enter. And my new minimum, which I'm going to write over here, looks to be still negative 1.25. Negative 1.25. I find that interesting, but kind of cool that it's the same x value. And that, I don't know, negative 65.9. So I'm going to negative 65.9, and that will be our new minimum there. And again, that is a global minimum. There are no local or global maximums here. And so we're going to stop right there. And let's analyze what happened there. All right. So just a quick review. What determines how many x intercepts? The degree of the equation. And I'm going to point something out, that the degree of this equation was a third degree equation. 1, 2, 3, and there are 3 x intercepts. This is a fourth degree. Look, 1, 2 is there, 3, and 4. And there are 4 x intercepts because there's 1 there, and this one occurs with a multiplicity of 2. So there's a total of 4 x intercepts. If you look at this guy, that's a degree of 1, and that's a degree of 3. So there are 4 x intercepts. There's 1 here, and this one occurs with a multiplicity of 3. So there's 3 intercepts there and 1 there. So what told me how many intercepts is the total degree of the equation, right? The total degree of the equation. And what determines the behavior at the x-intercept is the degree of each factor. So if it goes straight through, the degree at the factor is a first degree. Again, I'm going to point back and show you. First degree equation here went through at 1. First degree equation here went through at negative 3. All right. If it squiggles through, which we only had 1 on the other side, it was a third degree. But honestly, it could be a 5th degree or a 7th degree. They would all squiggle through. So I'm going to go back and show you that one over here. If you remember, that one occurred right here. It squiggled through at negative 5. I didn't draw the best squiggle, but that's what happened. It kind of looks like that. And if it bounces off, tangent means it touches the x-intercept once and goes away. It bounces off. That was a second degree. It's an even power. It could be a fourth degree. It could be a sixth degree. So this one would bounce off at 0, and this one would bounce off at -4. And I'm going to show you those on the other side again. All right. These guys bounced off at +4. It bounced. It touched but didn't go through. Over here we had one bounce off at +2. It touched but didn't go through. All right. So I'm going to end that note, and then I'm going to show you how quick it is to graph these. We can graph these very easy without a graphing calculator, and we're going to do this next. But I'm going to stop this one for right now, and we'll talk soon.